Welcome! In this video I'll talk about Appwrite, an open source backend-as-a-service platform. I will also talk about backend-as-a-service in general for those of you that are unfamiliar and haven't used backend-as-a-service platforms. We'll also discuss a little bit when these kinds of platforms are useful or when you should probably write your own custom backend. Appwrite has a cloud offering, which also has a free tier that's quite generous, but as it's open source, you can also self-host it. And you can self-host it on a virtual private server from whatever provider you decide, or you can host it yourself on some power-efficient hardware or home server, which is where this video sponsor comes in, Zima. Zima makes small, power-efficient computers, like this one, the Blade. It has an x86 Intel CPU, 16 GB of memory, and very generous I/O, including USB, networking, Type-C power delivery, and SATA. It's a perfect, small, efficient computer for a starter home lab. You can build network access storage if you're a video creator and you want to store your files somewhere. You can build a media server with Plex or Jellyfin to stream your movies and music collection. They have their own operating system, ZimaOS, which was previously called CasaOS, and it's a Linux-based, Debian-based system with an easy-to-use interface, especially built for home lab and home server use. You can check out zimaspace.com for all of their offerings. They have the ZimaBlade that I'm holding right here, ZimaCube Pro, and the Zima board. Again, special thanks to Zima for sending me the ZimaBlade NAS kit to show you guys in this video. A backend-as-a-service platform, as the name implies, allows you to build a backend, which you have to communicate with somehow, and that's where we'll start. The communication layers between the front-end applications that will use this backend and the actual backend. With Appwrite, you have a couple of options. It of course supports a REST API over HTTP. It also supports GraphQL over HTTP. On the real-time side, as it supports real-time, it uses WebSockets and it has support for something like chat apps or any real-time communication you might need. Now, these are the base protocols you can use for communication with any programming environment. But they also have SDKs that target primarily native mobile development and web development. Probably the most common module in all backend-as-a-service platforms is authentication. Any cloud application needs some form of authentication. Even if it's a single user app, you usually don't want it to be exposed to everyone. So the authentication module allows you to have application users with some roles. And Appwrite does have such a module. Let's dive into the specifics. First of all, the default fields for a user are ID, email, password, name, and phone. These are not extendable. You cannot change the fields of the user collection. Although we'll see in a bit, there is a database module where you can make a special table with extra user preferences, user data, or with whatever fields you like. For roles and access control, Appwrite supports the notion of teams. Teams are just groups of users you create, and each team can have individual roles. This is two levels of hierarchy of user roles and permissions you can utilize however you like, which should be plenty for all of your needs. There are a couple of nice security features like session length, different password formatting rules, and email alerts when a new user session is created. Speaking of email, you have email templates for operations related to authentication, like password reset, email verification, a magic URL, and others. Besides the basic email and password authentication, Appwrite supports multiple Auth 2 providers like Apple, Google, Microsoft, GitHub, and others. Now let's do a couple of demos. I will show you how to register and log in a user programmatically with the Appwrite Web SDK. Here's how we can authenticate with the SDK. Here I have a very simple web app that I've built. The application and all demos are available in a GitHub repository that is accessible through the video description. You can check out the link there. I won't focus on this web app. It's very simple, very straightforward. I'll just show you the basic SDK functions. And they're right here in this user service JavaScript file. Note there are SDKs for other programming languages and you can use the REST and GraphQL APIs. So me doing this in web doesn't mean you can only use it there. You can of course use this in your mobile app or native applications. We have to import a couple of things from the Appwrite SDK like the client, and we create a new client. This is basically the communication client. So I have my project ID here and endpoint. As I'm using the Appwrite cloud instance, this is the Frankfurt cloud endpoint for Appwrite. You can use your own endpoint here, of course. And then we create a new account. Notice this isn't a user account. This is the sort of accounts service in the SDK where you pass the client. All of the state, the session will be stored here, and you will use this account object to actually execute different commands and methods to create, update, and log in, sign up the user. Now I have a couple of simple functions here to show you how the SDK works. Here's how a sign up function can be implemented with that SDK. It's just a single async call. We await the account create method and we pass to it the user ID. Notice we have to pass a user ID. It's required. It cannot be null and generated in the database, but Appwrite has this ID object which has a unique method that can generate an ID in place, email and password, and that will create a user account. We can then sign in the user by another asynchronous method called create email password session. This will sign in the user and create a user session in the back in that account object, so you don't need to manage that manually, which is great. And this is email password session because we're implementing a simple email and password user authentication. You can of course set up different authentication strategies here like Auth 2 with Google, Microsoft, Apple, or maybe a one-time password sent to an email. But this is the most common authentication strategy, so I'm showing that. We have to just pass an email and password that we pass to this function, and we return response. Notice this function is basically just a proxy wrapper. You could avoid using it, but in most cases, you probably want some kind of a proxy or adapter between your SDK calls and what your application views actually call. And then we have a logout function, which is quite simple. We just delete the session. We can pass a unique session ID or the string current here to delete the current session. As you can see, quite straightforward. Now, in the front end, we can actually test this by creating a user with some test username and password. I can sign up now. Let me open DevTools. Signed up successfully. It's walked to the console by me, of course, and I get some response object. If I open my Appwrite console right here and go to Auth, I can see my new user right here. By default, it hashes the password with Argon2, so it's quite secure out of the box. We also have a sign-in view right here, nothing special. I can sign in with my user. Don't mind the sign up button, it's wrong. Just the label, and we get signed in successfully and another object. Now at this point I do have a session. I don't use it in this simple application right now, but if I attempt to sign in again, I'll get an exception that creation of a session is not possible while a current session is active. And I can log out and then I'll be able to log in again successfully. Let's now talk about the database. In a backend-as-a-service, everything is built around the database and based on the data that we're going to store there. And Appwrite has its database engine that is based on the relational MariaDB. You can build tables with fields and data types like any database, and it's integrated with user account control. So you have row permissions for user IDs, specific permissions, or based on themes and rows. And now I'll show you a demo on how to do the basic CRUD operations on database rows. So let's take a look at how the basic CRUD operations are done. We have to create a new tables.db object through the SDK, and through that object we can do all of the operations. For the demo, I've created a database called to-dos and a table called tasks. In fact, I can show you right here. If I open databases, I have to-dos, the ID is right here, and here I have the table tasks, which is just some dummy table. We can now create a task right here if we use the create row function, and we have to pass this table data, which is the database ID and the table ID to every operation. So I've extracted it to a constant at the top of my service file. And I have to pass the row ID. As with users, we have to generate a unique ID in place right here with the ID object, and in data we pass the actual fields as JSON. To list, basically read all rows, we can just use the list rows method, and we just pass the table data. This table ID is not needed here as it's included in table data. To get a task, a single row, we can use the same list rows method, but use a query. In this case, the query is quite simple. I check if ID, the ID fields, equals the ID I pass as argument, I pass as argument right here. And to update, we have an update row function, which is quite similar. All of these are very straightforward. We pass ID and data. For deletion, much like list, we just pass a query and Appwrite will remove this. As with users, you could use these directly or wrap them in some form of adapter like I did here, which probably I would recommend if you use an SDK like this. Now, of course, not everything is basic CRUD operations on your data. You sometimes need more complicated functions, and you don't need to write these in the front end necessarily for security reasons or whatever. You can write functions in Backend-as-a-Service platforms like Appwrite, and these functions are just executable code. You can think of them sort of like custom controllers, where you can use the Appwrite SDK internally, and you can call them from the SDK to execute whatever code you want. The good thing is these functions can be written in different runtimes and programming languages, and Appwrite supports plenty of runtimes. So you have the flexibility to implement custom functions in different programming environments and runtimes. Now let's take a look at a quick demo showing you what a function is and how to implement it in Appwrite. Here's an Appwrite function. This is the getting started Node.js function template. The different runtimes will be similar, so I'll show you that. It's of course a function which is asynchronous, and it accepts a couple of objects: request, response, walk, and error. And it does a couple of things. As an example, it creates a client, and we don't need to pass our API endpoint project ID, as these are available as environment variables in Appwrite. It creates a user client, and then it shows how to walk to the console and error loggers. We retrieve the users with users list, and it walks to the basically the walk of the Appwrite function, which is right here, where this function is created. On each execution, we have walks and errors. So basically, we walk in this logger, or we print to the standard error. Besides that, if the request path is ping, it will respond with a text pong. This request path is of course HTTP. So here we do some basic HTTP routing, and we can build a couple of simple endpoints. And finally, if the route is not this one, but any other route, it just returns some JSON with static text. And now we can test this. By the way, this function was completely bootstrapped from the Appwrite UI. You can create a function, select one of the quick starts, and it can create a GitHub repository for you where you can edit it and deploy it. And this ping function, if I open it, has a unique domain where I can open the root route, and we get the JSON, which is what we expect right here with the motto learn, connect, and get inspired. If I go to ping, we get the response text pong. And the other functionality, if we go to executions, we can see how many times it was executed. And on the root execution, we have a walk, total users 1, which is what we expect. So you can write whatever custom function you want and interact with it through HTTP. The other module in Appwrite is messaging. It supports push notifications through Apple and Firebase, but also email and SMS through multiple providers. You can set this up relatively easily through the Appwrite console and access them through the SDK. Storage is another important consideration in a backend as a service. and it has a whole module that's integrated with permissions and everything. You can store images, files, everything your application needs in buckets. You can manage their permissions, and the great thing is you can retrieve images with custom sizes, quality, and formats and transform them through the SDK. The storage module also supports compression, encryption, and antivirus, which are nice touches. Finally, I want to talk about the sites module. Similar to Vercel or Netlify, you can deploy a whole application through it, front-end web application, and it will detect what technology you're using, it will build your app, and deploy it automatically to an endpoint. It supports templates for Next.js, Nuxt, Astro, and others. Note that it supports not just static sites, but also server-side rendered applications. And now let's go to a demo. I'll deploy one of my Next.js projects as a test on my Appwrite instance, just to see how that would work. Here we'll go to sites. I haven't done this. This will be a live first test. Let me close my tabs and let's do create site. I have a couple of templates. Not templates, I have a couple of real sites in my GitHub repository, so I'll just use one of them. Let's search for personal website, for example. This is, I believe, a Next.js template. Yeah, it also detects that it's Next.js right here with an icon next to the repository. So let's connect that. And we can connect it. And it asks for the production branch, which is main root directory. And it detects the framework. Here are all of the supported frameworks. You can also choose other and I believe configure it manually. But I'll choose Next.js. And we can also choose a custom domain, subdomain. I'll do personal website test. And we have the option to customize the build settings and set environment variables, which is very convenient. But let's now deploy and see how that would work out. So here it will build the app. I might speed this up and I'll pick this video up when it builds successfully. All right, the build took a couple of minutes, but it succeeded and deployed the site on the appropriate domain. As you can see quite easily, we can deploy server-side rendered apps or static sites through this sites module right here. So these were the main modules of Appwrite, and I tried to cover and show you the most important capabilities and information related to this backend as a service. Now, I want to also discuss use cases for this and competitors. As for competitors or alternative backend as a service solutions, here we are talking in the commercial space about a lot of possibilities, including Firebase and many others. But in terms of open source, and things you can self-host, you pretty much have Appwrite, the main competitor, and the bigger name in this sphere is probably Supabase. Supabase is different in that it tightly integrates with Postgres, the database. It has maybe a little bit more features here and there, but also lacks some features in some of the modules. On the other hand, it's also a little bit heavier in my experience. On idle, it has higher CPU usage and memory usage, and in general, it is able to sustain fewer requests per second on a given hardware. I've seen this article, which shows a comparison in terms of performance for a simple e-commerce app between Supabase and Appwrite. And Appwrite comes on top in pretty much every category in terms of performance and resource usage. Now, another lightweight solution is PocketBase. It's a single executable SQLite, very lightweight solution that lacks a little bit of features, but it's amazing in terms of performance, in terms of being lean and easy to deploy. The good thing about PocketBase is that it's small and performant. The bad thing is it lacks features here and there, but for small to medium-sized projects, it's actually quite great and a good performant option. But Appwrite, in my opinion, is sort of this middle ground where you get good performance, open source, but also cloud options with a free cloud starter. And the feature set is quite complete, and I've had a very reliable experience while testing it. Note, I have not built an actual application with Appwrite. I usually like to write my backends custom and tailor them, optimize them as much as possible. Now, here we go to the other topic I wanted to discuss, use cases. Should you use this, in my opinion, and when? And I think when should you use this is more important than if you should at all. There are use cases when I think a backend-as-a-service platform is applicable and you should consider it instead of writing a whole custom backend. The reality is not every project is made to last ages and be used by millions of users. And in many cases, you would be building something like a proof of concept, whether that's for an investment pitch, whether that's for a coursework in university, or just a small project you want to test and you don't know if anyone on earth would want to use. And before you have 1 or 2 users, you could probably build a backend with a backend-as-a-service platform. And if it gains traction, users, you can always migrate backend to a custom backend later and rewrite it. This is one use case. I would say probably the strongest use case for a backend-as-a-service is a quick, just a quick prototype, a quick proof of concept you need to build for someone else or for yourself. Also, internal business applications. Every business has a couple of small apps you use for whatever internal workflow. This is great for it because there you don't care about that much about performance, customization. You can make a few compromises on that front. For speed, efficiency, just deploying something very quickly and adding new features in a very rapid manner. In these cases, I think a backend-as-a-service is a good choice because these basic things like authentication, basic database access is already implemented and you can quickly bootstrap it. On the other hand, a custom backend, you have more control with modern libraries, languages like Go. You can get a very performant backend that is infinitely custom, completely under your control, and you know the entirety of the code base. You will have to do extra work. You will have to make sure it's secure yourself, but you will always have better flexibility, more scalability in the future, and infinite flexibility in terms of deployment. So for serious big applications which are already maybe established and you know will be used by a lot of people, I would always go towards a custom backend, and I am actually in all of my projects that I'm serious about and are production projects, I have built custom backends with different technologies for them. That's just my 2 cents though. Let me know in the video description, do you use a backend-as-a-service platform? Why do you think it's good, bad? What kind of platform do you use? I'm very interested to learn that because, as is evident, I'm also interested in these platforms and I'm considering using it for some prototypes and proof of concept work. I will leave you with that, and as always, take care.